Okay. This is the, now we are going to move on to the Turing machine. So here till this point we have discussed the finite automata, next comes the push-down automata. Now what we are going to deal is the Turing machine. So what for we discussed the finite automata. So for finite automata is for the regular languages. Okay, finite automata is for the regular languages and push-down automata is for the context-free languages. Okay, context-free languages. And now Turing machine is for the recursive languages or recursively enumerable languages. Okay, so here we are going to discuss Turing machine. That is, here in this case of the, as discussed earlier, this Turing machine is going to be the previous version of our computers, current day computational devices. Okay, so using the Turing machine, we can perform any of the tasks. So computation, arithmetic operations, we can perform. So what is the advantage of this? So what makes the difference between the Turing machine and finite automata and push-down automata? In the case of finite automata, only the current state is known to us. We cannot move forward or that is traversal is not possible. Only the current state and current input symbol is known to us. Whereas in case of push-down automata, I will be able to know the topmost element. I'll be having a data structure that is stack. So using that stack, I can check for a given specific pattern. Okay. Consider this particular sequence: A power n, B power n, C power n. Can we define a push-down automata for this one? Can you write a context-free grammar for this?
Yes, ma'am.
Can you please write it? A power n, B power n, C power n. All three should be in same count. All of you, please do try writing the context-free grammar for this. First, try write for A power n, B power n. Okay. Then proceed with A power n, B power n, C power n. What is the grammar for A power n, B power n now?
I can't write. No.
Okay, so for A power n, B power n, it is S derives A is B. S derives A is B. So this is for A power n, B power n. So can we proceed for A power n, B power n, C power n? Is that sequence possible over here? At the same time, I have no, it is not possible, right? So it is a recursive language. It is not. So for we can say it is not a context-free language. Okay, it is not a context-free language. So here there is some more restriction. So what is that? So we have to compare the number of A's, number of B's and number of C's. So as it is not a context-free grammar, it is not possible, context-free language, it is not possible for us to design the push-down automata. How we used to construct the push-down automata. So if I want to compare A power n, B power n, what I will do? I will be pushing all A's inside the stack. Whenever a B comes, I will be popping of A from the stack. So at this stage, after comparing A's and B's, my stack will be empty. Can I compare the number of C's? No, it is not possible, right? So we cannot construct the PDF for this particular language. There comes the role of the Turing machine. So what is the advantage of the Turing machine? The case of a Turing machine, I will be having a magnetic tape. Okay, so it is an infinite length tape, which is not the length of the tape is not restricted. It is an infinite length tape and it is open ended. Okay, both sides is open. So here there will be a tape head. So the infinite length tape will be a tape head. This tape head, so as you all aware, in the case of the stack, I can only access the topmost element of the stack, right? Whereas in this case of magnetic tape, I can move towards the right, towards the left. Okay, my tape head can move in this direction and then it can move in this direction. Okay, so by this so what I will do is, if I want to perform any operation, I will be placing my input symbols inside the tape, and then I will be performing. I can traverse through all the input characters. Okay, so I can traverse through. So this is the advantage of the using this magnetic. Because of this magnetic tape, we can perform any of the tasks. Okay. So here this is the formal definition of Turing machine. Right. So here these terms already we come across, that is Q, sigma, delta, Q naught, F, or all already we come across, right? In the case of Turing, what is it, finite automata, Boolean automata, you are already familiar with. The new terms we come across is tau and b, that is the blank symbol. So please do perform a comparison between this and the previous machine, that is PDA. So in the PDA we come across the, so what is the formal definition of PDA? Hope you can recollect it, right? Yes. So here we come across two symbols. So here in this case, tau is the stack alphabet. Okay, here Z0 is the start symbol of the stack. That is start symbol in the sense bottom of the stack is designated by Z0. When I reach the Z0, what I can infer, I am in the bottom of the stack. Okay, so here tau represents the stack alphabet. Whatever I put inside the stack is going to be called as the stack alphabet. Okay. And another thing, it is not mandatory that only my input symbol should be acting as the stack alphabet. Based upon the convenience, I can push anything inside the stack. So here even you can see, so instead of A, I can put what is our target. For each and every A, I have to push something inside the stack, so that whenever I encounter a B, I have to compare with the elements pushed inside. Okay, so here in this case, we have pushed A's inside the stack. So instead of A even, we can push any of the stack alphabet inside the stack. Any other symbols which is not in the input symbol can be pushed inside. Okay. Uh, yes. Similarly, here we are talking of tau, which is the tape symbol. Okay. In addition to the input symbol, so it is not only sigma. In addition to sigma, I'll be having some other symbols. Okay. Yes. So here these are the 7 tuples. SQ is the set of states, and tau represents the finite set of tape symbols. Sigma represents finite set of input symbols and tau represents finite set of tape symbols. In the previous case, tau represents the stack symbols. In this case, tau represents the tape symbols. Delta represents transition function. Q naught star symbol. B blank symbol. Here, yes, blank in the sense the empty slots in the tape will be filled by blank. Okay, so yes, that's what I'm saying. So only if I explain with my pen, it will be clear for you. Actually, I'll be having, for example, A, A, B, B, C, C, right? I'll be placing it inside the tape. The rest of the places will be filled with blank. Okay, rest of the places will be filled with blank, and based on the requirement, I will be making the existing uh, uh, already filled the slot to blank one even. Okay, it will be clear for you when we see further example. Okay, so blank symbol. So here you can go for any of the blank symbol, right? So here, yes, here we have proceeded with capital B as the blank symbol. When we refer books, each and every book will be following different convention. Okay, any symbol can act. So, but the case is that blank symbol should not be used as the input symbol, or it should not be that is for any other operation. It should not be used with. That particular symbol should be used only for representing the blank slot. Okay, so that is the blank symbol. So this blank symbol will belong to the top. That is the tape symbol. Okay, is my voice clear? Am I audible?
Yes,
Yes, ma'am.
ma'am.
Okay, yes. Right, so here what I'm going to do is I'm going to compare this, just a sample, right? We can see it in detail later. So what I'll be doing is I'll be placing, so this is let me got A. Okay, so it is going to be blank. So here what I can do, so mine, this is the initial configuration. Okay, so this is my initial configuration. This is my tape head. So what should I do? I have to compare. So what is my target? So I have to compare. I have to check whether there are equal number of A's, equal number of B's, and equal number of C's. Okay, that is my target. So what I'll be doing is, so whenever I come across A, okay, so here if I come across A, there should be one B and there should be one C, right? There should be one B and one C. And similarly, if I come across this A, there should be one B and one C. Like this, I have to proceed with comparison. If I already compared an alphabet, for example, if I compare this A with this B with this C, then I have to designate it. I have to mark it. Okay, so already visited slot should be marked. Only then I can infer that it is already compared. Okay, considering that, what I am going to do is, if I visited a slot, if I perform comparison of a particular input alphabet, I will be marking it. So for A, I will be marking it as X. For B, I am going to marking it as Y, and for C, I am going to mark it as Z. Okay, so here you can see, so this is my tape head position. So what I'm going to do is, so this is the input symbol I am coming across. Okay, I have to mark it. So what I'll be doing is, I'll be replacing this A by X. That is what we are doing here. A is written, so we are rewriting it. Okay, so this is overwritten by X. So instead of A, I will be replacing it by X. What is my target? I have to just compare the number of, I have to check whether the number of A's, number of B's, and number of C's are equal. That's it. Okay, so for that I am going to proceed. So this A is going to be replaced by X. Okay, then I am going to move my tape head towards the right. Until which position I have to move my tape head? Till I reach B, I have to move my tape head towards the right side. That is what we are doing. After rewriting it, I am going to move my tape head towards the right. Now my tape head is in this position. I am in state Q1. What should I do? Whatever may be the number of ways, I have to move my tape head towards the right. Till I reach B, I have to perform the same task. That is what we are doing here. A, B. That is A in the sense we are not performing in, that is we are not rewriting with any other alphabet. The same alphabet is going to be present. A, just move the tape head towards the right side. Okay, now my tape head is in this position. Yes, now I encounter B. Okay, my encounter B. So what should I do? I have to mark it. So actually what is my target? I have seen A, so I have to check whether I am having one B and one C. Okay, that is my target. So if I am visiting a B, what should I do? I have to replace it by some other, that is I have to mark it. Okay, so here in order to differentiate between A, B and C, I am going to use different marker. Okay, so here this B is designated by 1. Okay, this B is designated by Y, and then I'm going to move my tape head towards the right side. So here again, whatever may be the number of B's, I have to move towards the right side. That is what we are doing here. Okay, just move my tape head towards the right. Yes, now I am in C. What should I do? On encountering a C, I have to move my tape head towards the right side. Okay, so on please make a note over here. Whenever I encounter a C, so this is my first C, what should I do? I have to change it as Z, right? And then I have to move my tape head. Where should I move?
Back to A.
Yes, I have to move my tape head towards the left side. Okay, so I have to move my tape head towards the left. So that is what we are doing here. Yes, so here what we are doing, so yes, now my tape head is in this position. So what should I do? I have to move my tape head till I reach this position. Okay, how I can identify this position? So only if I reach this position, I can move on to this particular position, right? So I have to move my tape head till I reach X. That is what we are doing here. If I encounter B, just move left. If I encounter Y, just move left. If I encounter A, just move left. Okay, like this I'll be in this position. Okay, I'll be reaching this particular position. Now what happens? I'm encountering a X. Okay, I'm encountering a X. So what should I do? On encountering a X, I have to move my tape head towards the right side. Now I am in this position. Okay, now I am in this position. So what should I do? This is my next A, right? So what should I do? I have to move my tape head. So I have to change it as X, and then I have to move my tape head towards this position. So please make a note that needs to be included here. I have missed it here. So what should I do? If I encounter a Y, I have to move my tape head towards the next position. If I encounter a B, that should be changed to Y, and then I have to move my tape head towards the right. Okay, sorry, I'm not comfortable with here, so only if I'm having a pen, it will make sense, I hope. Okay, hope you got some idea, right?
Basically, from Q1 to Q2, there should be another Y/Y, comma R.
Yes, that's what I'm saying. So I missed
Okay.
here. I have missed here.
Okay,
Okay,
ma'am.
that needs to be included. So Y, only then I can move towards the right side where I will be encountering a P. Okay, so if everything is traversed, okay, so here is, yes, here you can see, yes, I have marked everything. So on I'll be in this state, right? So after marking this C as Z, what should I do? I have to perform, I have to traverse towards the right, towards the left in order to check whether any other A is present. Okay, so that's what we are coming over here. So here I am traversing towards this side. So what will I do? When I encounter X, I will be moving my taper towards right side. So when I am in this position, that is I am in state Q3, I am encountering X. So what should I do? I have to move my taper towards this position. So I am in this position. So what is the thing? So what is the meaning over here? We have traversed through all the X, all the Y and all the Z. Sorry, all A, B and C. Okay, so what is the thing? So here you can see y. So please make a note over here. What is our target? I should have equal number of A's, equal number of B's and equal number of C's. So if all are equal, what will be my sequence? I will be having only sequence of X, I will be having Y and Z. Can you all get me? If there is variation in number of A's, B's and C's, I will be having remaining B or C or A. Okay, so if all are of equal count, I'll be having only sequence of sequence of X, Y and Z. That we are going to check over here. Okay, so here in this case I am moving taper towards the right, I am encountering a Y. On encountering a Y, I am moving on to the next state, that is Q4. After that, I will be traversing. So where I am traversing? So while traversing, I will be coming across only Y and Z. So I will be performing the same process till I reach the blank symbol. On encountering a blank symbol, I can confirm that the number of A's, B's and C's are of equal count. Okay, so please do try constructing. We can discuss in detail in the next class. Okay.
Yes, ma'am.
Okay, ma'am.